Hi, welcome to my channel Mathematics Made Easy by Mary MJ. Today I am discussing class 11 chapter 13 limits and derivatives. It's a very important chapter because in 12th standard if next year you are having derivatives, differentiation is there, that is chapter number 5. Then along with that applications of derivatives, then continuation of that integration, then applications of integration, then differential equation, like that way sequence of chapters based on this topic. So you have to be very thorough with this chapter. Around half of the total marks it is for calculus. This area comes under calculus. So limits and derivatives is having very importance, and if you are going for higher studies also in maths there will be differentiation, integration, it will be continuing. So study well, and each and every concept of this chapter you have to make it thorough. So moving on to this chapter, before that we have studied in chapter 2 about domain, range, what is a function, this all we have explained. And there we know that a function means f of x equal to, let it be 3x plus 2. And if I am giving values for x, that is if x equal to 0, I will get what is f of 0. F of 0 means 3 into 0 plus 2, that's equal to 2. So the value of this particular function at x equal to 0 is 2. So this we called as value of the function. Value of function. Or at x equal to 1, we are getting f of 1 is equal to 3 into 1 plus 2. That is 3 plus 2 is equal to 5, and this is called the value of function when x equal to 1 or when x equal to 0. It's called value of function. Here we are discussing what is limit. Limit means when x is tending to a particular value, that is x is tending to a particular value means x is approaching to a particular value. That is, if I am drawing a number line, this is 0, this side it is positive value 1, 2, 3, etc. This side is minus 1, minus 2, minus 3, etc. So tending to 0 means I can either tend to 0 from the left side or it can tend to 0 from the right side. It is approaching to 0. So this is either tending to 0 or approaching to 0. Approaching to 0 from left or right side. From left side or from right side. So that's called limit. And how do we represent limit? Representation of limit. So representation of limits. Usually we write limit of function, that is we will write it as LIM, limit x tends to 0 f of x. So when x is tending to 0, what is the value of the function? What is function f of x? That's called limit. So that whether it is approaching from the left side or from right side, what is the value of what is function f of x? Then we can write like this way, or another way of writing the limit is LT, limit x tends to 0 f of x. Both represents the same. Value of the function, in some cases value of the function will be the same as the limit. Actually it is not both. Even though we are getting the answer as same, does not mean that it is equal. Okay, so suppose I am drawing a graph here. It's a graph of a particular function, some function, and at this point here x is equal to a. At that point, this function here, it is touching at L. So here when x is tending to a particular value, what is the function, what is the limit of that particular value? That's L. So limit x tends to a, this function, this is a graph of some particular function. When x is tending to a particular value, what happens to f of x, or what is the value of f of x? That's we call it as L. So this is called limit. Limit x tends to a particular value, what is f of x, and that is called L, that is L. Okay, there are few results. Some results are there to learn about this limits. What are those results? First result, if f of x equal to k, that is k means a constant, k is a constant. If f of x is equal to k, a constant, then limit x tends to a, f of x is equal to that constant itself. Why it is so? Because limit x tends to a, constant means f of x is k, means f of x equal to constant means it is k. So here there is, I don't have x value to substitute here. So the answer is k itself. If I am able to substitute k, x as a, then only I can substitute, otherwise the same value will come. Or if it is limit x tends to 4, function given, let it be f of x equal to 5. So what is the answer? It is 5 itself, because there is no x value to give. Then now second result, limit x tends to a, k into f of x is equal to k into limit x tends to a, f of x. So a constant into a function. So what you have to do, that constant we have to take it outside, then limit x tends to a, f of x. So limit x tends to a, k into f of x is the same as k into limit x tends to a, f of x. Then next result, limit x tends to a, f of x plus g of x is equal to limit x tends to a, f of x plus limit x tends to a, g of x. We can separately add, that is two functions, we can separately apply the limits and add. Then same way in the case of subtraction also, f of x minus g of x means limit x tends to a, f of x minus limit x tends to a, g of x. Separately we can apply the limit and then subtract. So the fourth one is limit x tends to a, f of x minus g of x is equal to limit x tends to a, f of x minus limit x tends to a, g of x. Same way it is applicable for multiplication and division also. So what happens in the case of multiplication? Limit x tends to a, f of x into g of x is equal to limit x tends to a, f of x into limit x tends to a, g of x. Same way in the case of division also, limit x tends to a, f of x divided by g of x is the same as limit x tends to a f of x divided by limit x tends to a g of x. So these are the few results. Out of this, the first and second are very important. Remaining we will be applying. Accordingly, we have to apply in the problems which it is being given. So all these results you have to learn it and apply in the problems. Okay, now next is limits of polynomial functions. Polynomial functions. So how to apply limit for a polynomial function? I'll show you one example. Textbook example itself. Find the limits. Find the limits of the following. First one, limit x tends to 1. A polynomial function is given as x cube minus x square plus 1. So here directly we can give the value x equal to 1. So this can be written as limit x tends to 1. If I am giving x equal to 1, x is tending to 1 here. So this can be written as 1 cube minus 1 square plus 1, or that is equal to 1 itself. Then, so polynomial functions we can directly apply the result. Apply the limit. Then second one, limit x tends to 3 x into x plus 1. Here also we can directly apply the limit. So limit x tends to 3. Instead of x we can give the value of 3. So the function here is x into x plus 1. So while after applying the limit, don't want to write again limit x tends to 3. So directly we can apply here. So 3 into 3 plus 1, and the answer is 3 into 4, that is 12. Then, so this is polynomial functions. So polynomial functions we can directly apply the result, apply the limit. That is, if what x tends to 1 or x tends to 3, we can directly give the value. Now next is limit of rational functions. Limits of rational functions. So we should know what is a rational function. So rational function means, as all of you know, f of x is equal to g of x divided by h of x. It is a rational function. So how to apply limits for rational function? So let us take an example. Let f of x equal to, this is an example, f of x equal to 3x by x. So limit x tends to 0 f of x. What is limit x tends to 0 f of x? That is equal to limit x tends to 0 3x by x. If I am giving here 0 for x, same way as the last one, if you are doing here, I can give x as 0, here also 0. So what happens? 0 by 0 form. This is 0 by 0 form. So 0 by 0 form we call it as indeterminate form. Indeterminate form. So such a case, what we have to do? We can't directly apply the result, apply the limit. So in that case, we are having 3 methods. So if it is a rational function, check whether it is in the 0 by 0 form. If it is in the 0 by 0 form, we are having 3 different methods to rationalize, to simplify. There are 3 different methods to simplify. First one is factorization. Factorization. Second is factorization method. Second method is substitution. and third method is rationalization. So there are three different methods to find the limit. So in the question it won't be asked to use this method or that method. We have to find out which method we have to use. So in this question we can just simplify this we can cancel this x, that's called factorization, that is 3 into x by x, those two can be cancelled and we can write the answer as 3. So if it is if it is a rational function, we have to go for any of these three methods, either factorization method, substitution method or rationalization method. So I'll show you where all we have to apply these three methods. So according to the question we have to use. So the first one, this is all example questions of the textbook. Limit x tends to 2, x square minus 4 by x minus 2. So as earlier we can give the value of 2 here. If I am giving the value as 2 here, what happens? If I am putting the value as 2, 2 square minus 4 divided by 2 minus 2. And that is 0 by 0 form. This we are getting it as both as 0, numerator and denominator we are getting as 0. So it is 0 by 0 form. If it is in 0 by 0 form, either we have to go for rationalization or substitution or rationalization. So which one should be used here? So again I am taking this limit x tends to 2, x square minus 4 by x minus 2. Seeing this, we know that we can factorize x square minus 4. How can you factorize x square minus 4? Or we know what is a square minus b square. A square minus b square is a plus b into a minus b. So x square minus 4 can be written as x plus 2 into x minus 2. So this limit x tends to 2. I am factorizing x square minus 4 as x plus 2 into x minus 2 divided by denominator as such. Now we can see that in the numerator and denominator x minus 2 is common. So I can cancel this x minus 2. So this is called factorization and simplifying. So now when x tends to 2, we are getting the answer as 2 plus 2, that is equal to 4. So limit x tends to 2, x square minus 4 by x minus 2 is equal to 4, and we have used the method factorization. So it won't be told that this method you have to opt for or the other method you have to opt. You have to understand which one should be used. Okay, now next one. Next question. Limit x tends to 1, x square plus 1 divided by x plus 100. So first thing is that we have to give the value of x. X tends to 1. So we have to give x equal to 1 here, and we have to check whether it is in the normal form or whether it is in 0 by 0 form or indeterminate form. So we have to find it whether we are able to directly do the question or not. So giving x equal to 1 square plus 1 divided by 1 plus 100, and that is equal to 2 by 101. So we can directly apply the limit here. So it is not in indeterminate form or 0 by 0 form or infinity by infinity form. So directly we can give the limit and write the answer. Now next one, limit x tends to 2, x cube minus 4x square plus 4x divided by x square minus 4. So again we can give x equal to 2 here and check whether it is in the 0 by 0 form or which form it is. So here 2 cube minus 4 into 2 square plus 4 into 2 divided by 2 square minus 4, and that is equal to 8 minus 16 plus 8 divided by 4 minus 4, that is in the 0 by 0 form. So we have to go for any of these methods and we have to check which method is more suitable here. Here in the numerator x is common, so I am taking x outside, remaining x square minus 4x plus 4 divided by x square minus 2 square. And we can factorize this. Limit x tends to 2, x into x minus 2 whole square divided by x minus 2 into x plus 2. In the numerator and denominator we can see that x minus 2 is common, that can be cancelled. X minus 2 can be cancelled from both the numerator and denominator. So remaining what you will get, x into x minus 2 by x plus 2. Again applying that limit x equal to 2 here. So we are getting 2 into 2 minus 2 divided by 2 plus 2, that's equal to 0 by 4. It is not indeterminate form or infinity form or not. It is having the answer 0 by 4 means it is equal to 0. Then next one, limit x tends to 2, x cube minus 2x square divided by x square minus 5x plus 6. So applying 2 here, giving the limit 2 cube minus 2 into 2 square divided by 2 square minus 5 into 2 plus 6, and that is equal to 2 cube is 8, 8 minus 8 is 0 divided by 4 minus 10 is minus 6, minus 6 plus 6 is 0. So again 0 by 0 form. So we have to go for factorization. Limit x tends to 2. Here x square is common, remaining x minus 2 divided by x square minus 5x plus 6 means factors of 6. Factors of 6 are minus 3 and minus 2. So x minus 2 into x minus 3. And cancelling this x minus 2 from numerator and denominator, we are getting limit x tends to 2, x square by x minus 3. Now giving the value for x as 2, 2 square divided by 2 minus 3, that's equal to 4 by minus 1, which is equal to minus 4. Now next one, next question is limit x tends to 1, x minus 2 by x square minus x minus 1 by x cube minus 3x square plus 2x. Again if you are putting 1 over here, 1 minus 2 divided by 1 minus 1. So denominator here it is 0. Here 1 minus 3 plus 2, again 0. So denominator if it is 0 means we are getting in the numerator also. Here 1 minus 2 is minus 1. So it is in indeterminate form or it is not defined. So we have to go for either factorization or any method. So here only factorization is, we can do only factorization here. So for that what we have to do is take this, I am not applying limit now, I am taking that inside part separately. X minus 2 divided by x square minus x minus 1 by x cube minus 3x square plus 2x. Now this can be written as x minus 2 by x into x minus 1 minus 1 by, here also x is common in all the three terms, so x into x square minus 3x plus 2, that is equal to x minus 2 by x into x minus 1 minus 1 by x into x square minus 3x plus 2 can be factorized as x minus 1 into x minus 2. Now seeing both the denominators, we can take the LCM. What is the LCM for both? X into x minus 1 and x into x minus 1 into x minus 2, LCM will be x into x minus 1 into x minus 2 is the LCM. So here what should be multiplied? There should be x minus 2 whole square. Here already one x minus 2 is there. Numerator and denominator I have to multiply by x minus 2 to make the denominator as x into x minus 1 into x minus 2. So that numerator also it is being multiplied. Okay, here minus 1. That is equal to numerator, I can open the bracket. So x square minus 4x plus 4 minus 1 divided by x into x minus 1 into x minus 2. And that is x square minus 4x plus 3 divided by x into x minus 1 into x minus 2. And this we can factorize. X square minus 4x plus 3 can be factorized as x minus 3 into x minus 1 divided by x into x minus 1 into x minus 2. X minus 1 we can cancel. Now we have to apply the limit. Here it is given limit x tends to 1. So limit x tends to 1, x minus 3 divided by x into x minus 2 is equal to, giving the value of x as 1 minus 3 divided by 1 into 1 minus 2, that is minus 2 by minus 1, and that is equal to 2. So these questions were example questions, and the remaining chapter will be discussed in the next video. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.